Yep, mic is registered. So thank you everyone for coming to today's lecture. My name is Dylan Agnes. I'm a research scientist here at the University of Idaho Integrated Design Lab. I'm going to do a kind of an abbreviated introduction since everyone in person is familiar with our programs and they're really only applicable within the state of Idaho. We do hope you'll continue to show up for BSUG, our Building Simulations Users Group. This is sponsored by Idaho Power. Their funding allows us to present these lectures as well as other programs and provide food for those in person. So thank you very much to them. So without further ado, I'd like to introduce Mostapha. He's a co-founder of Ladybug Tools LLC. He started the development of several open source programs, including Ladybug, EPW Map, and Design Explorer. After receiving his master's in environmental building design from the University of Pennsylvania, he worked as a senior designer for Adrian Smith and Gordon Gill, and as a integrations applications developer for Thornton Tomasetti Core Studio. He was a lecturer at the University of Pennsylvania and is now working full-time at Ladybug Tools. So thank you very much, Mostapha, for agreeing to do this lecture. Me personally, I'm really looking forward to it. I'm sure everyone else is. Before I allow you to get started, though, I just got a notification someone was requesting to record the lecture. We are recording the lecture and we post them on our YouTube channel within a week. So you'll be able to look at it that way. So visit idealboise.com to find the link, or go to YouTube and do UI IDL is our channel. All right, Mostapha, take it away.
Okay, great. Thank you. So can you see my screen already?
Yes, I can see it.
Okay, great. Thank you everyone for coming. This is about an hour. I'll take about 45 minutes to present, and I think we will have 15 minutes for Q&A. But at any point, I think you can post your questions to chat, and I'll probably be seeing them as I'm presenting. You probably have seen me with this logo from 2013 with Ladybug. For some of you who don't necessarily know what's Ladybug and Ladybug Tools, Ladybug Tools is a series of plugins for Grasshopper, and Grasshopper is a plugin for Rhino. They cover different aspects of environmental building design and simulation. You can start from climate visualization and analysis, building energy, daylight, comfort modeling, then butterfly for airflow, and dragonfly for urban modeling. We also started a project, Spider, for web visualization. I think the most successful and popular part of Spider is the GBXML viewer, the online GBXML viewer that you can use. So Ladybug Tools from 2013 to 2023 started from a single small plugin to a network of different plugins that works together and connects to all these different engines. And the key here is to be able to take data from somewhere, send it to other place without the need of like getting out of the platform, going to another platform. And I think that's one of the reasons of the success of Ladybug Tools. It has been downloaded more than 620,000 times, only from Food for Rhino. It has 3,000 monthly active forum members, 25 topics per day, 6,000 views per day. And all of that happened for a project that I really started for myself as a small project. The other project that I have been involved in that probably you have seen it or you have seen similar user interfaces pop up in other software is Design Explorer, which I developed when I was part of the Core Studio. And we needed this for a real project that we were working on. And we needed the UI for the customer to be able to basically pick the best options from thousands of iterations that we ran for them. And that's how Design Explorer was basically created. And similar to Ladybug Tools, it became very popular. Both those projects started as personal projects or like projects specific to solve a very specific problem or a very specific problem for a single project, and became something that the industry started to use. But then we have Pollination, which I will talk about more here, which we started in 2018. And this is, I think, the first product that we started with the idea of solving the problems that we saw in the industry after years of developing Ladybug Tools and using it on the projects ourselves and helping other people to use it on the projects. So what is the main problem that we're trying to solve? we call it the 2-week workaround. This is how it goes. You know, you have the engineering and architect, they can be in the same office, they can be in different offices, there's deadline, everyone is happy, you know, like this is before the deadline, we need X, Y, Z. And then what happens is the engineering side or building performance simulation, whatever you want to call it, in the bottom, they just wait for a design option. And at that point, the design options usually sometimes a 2D drawing, sometimes a CAD file, sometimes a Revit model. Whatever that thing is usually doesn't really work for what you need. So you don't use it right away. You come back to office, you say, okay, we're working on this, and you redraw the whole thing. And before I used to have this slide and say like clean up the model, but really like most of the models that we have, everything gets redrawn from scratch. And that's really sad to say the least. And then you have this small time of running the study, you send it back, and that time you have between 2 weeks to a month that you were not able to provide any feedback. And you know what happens at that point, the design has changed. And because the design has changed, you need to run the studies again. And then at that point, they sent you a model, usually in the middle, close to deadline, you just ignore it because you couldn't. And after the deadline, you go and start doing the same thing again. And we do this again and again. So this is the problem that we are trying to solve. And as you can see, the issue is not really running the simulation faster only, but it's one major one is redrawing the model. The other one is how we communicate together during this process. So what is Pollination? Pollination is an ecosystem of tools for environmental building design and simulation. It is an AND platform. What's an AND platform? It means like it has different things next to each other. It's a collaboration platform. It's a collection of CAD and BIM plugins. It's an app store, and it's a cloud computing service. It's all the above together. It's also built on top of accurate and validated engines. It's built using modular and reusable logics. It's customizable. And finally, it is easy to use. And you might be thinking, how is this possible? I know that. But before I go there, I want to talk about why this is important. Because if we think about the tools, the existing tools that we have, right? And we have these 4 circles for easy to use, accurate, customizable, and automated. You have a pattern of tools that are easy to use, and then these easy to use tools are usually presented to people who are not experts, to people who don't know what they're doing too, right? So add easy to use with a user who doesn't know what they're doing, you're making garbage in, garbage out. Then you have easy to use and put it in an automated way. Now you have easy to use, automated, and uneducated user. You have garbage in, garbage out this time on a steroid. If you go here and just build the tools that are not easy to use, but they're really accurate, right? The limitation there will be this use will only or mostly be used by experts. Then you go here between the area of making things easy to use, automated, and still keep them accurate. Then you have to keep the scope of the tools very limited. Because as soon as you start to add to the scope, either the person needs to know a lot so it's not that easy to use, or you have to just give up on accuracy, right, of how things are. Then we have this side that you build things that are accurate and customizable and automated. And these are usually the thing that is used by geeks, because to be able to use that, you need to understand simulation well, you need to understand programming, you know, like you have to know a little bit of everything, and there are not that many people who can do that. I think Ladybug tools, we try to just address that to make it easier by using a visual interface for that. But then Pollination tries to stay in the center to basically try to address all the above. But as I said, like we all know about this, right? You say if it's something good and fast and cheap, it's basically not possible. You have to pick 2 all the time. So how is that I claim that Pollination can do all this? Because when I talk about Pollination, I really talk about an ecosystem of tools that are built on top of each other. So we build on top of simulation engines, the validated simulation engines that are not really developed by us. We use Energy Plus, Open Studio, Radiance. We have a connection to OpenFOAM. And Ladybug Tools libraries, one thing that I didn't mention is Ladybug Tools not only have the Grasshopper plugin, but it also has a series of Python libraries that can be used outside Grasshopper. And those are the ones that make it easy to access to these validated engines. Then we have SDKs and APIs developed on top of that makes things customizable and programmable. Then we have pollination recipes that basically puts this codes together to create units of logics that makes them reusable. And finally, you can build on top of this, pollination apps and use Ladybug tools and build Grasshopper script that makes them easy to use. So this part in the bottom took years to develop and still is under development, some partially and mostly used by expert. This part on the top now takes days to develop if you want to build a script or build an app, and can be used by non-expert. And that's part the easy to use comes. This is the part that validated and customizable comes together. If you want to know about like the pollination when it started, so we basically explored what can happen from 2018 to around 2021 when we had the initial beta release. And then we have been iterating over and over during the last 2 years. And now the last year, it has been a product adoption and refinement. The pollination was partially or mostly funded by an SBIR grant from the Department of Energy, which was really helpful. And I would like to thank them for letting us do this in a shorter amount of time. So one thing before I go ahead, and I know people are, mostly the Ladybug tool users are very concerned about that, is that is pollination going to replace Ladybug tools? And the answer is no, absolutely not. They are actually working together, and Ladybug tools is the core, is the root for pollination. So pollination is built on top of Ladybug tools. Anything under Ladybug tools is open source and is free. Anything under pollination is a commercial product. Some of the pollination products are free, some of them are open source, but they are all commercial products that we built on top of Ladybug tools. So I hope this, first of all, gives a better feeling to Ladybug tools users, and also clarify the differentiation between the two, or the differences between the two. Okay. Yeah, this is one of my new slides. I don't know how good it works, but I think like one of the main points that makes pollination different, and like how we think we should approach this problem, is we don't think simplification is the solution. It's not about simplifying the problem. It is about streamlining the process. That's what we are trying to do, and that's why we developed the tools, and that's the vision behind the development of how we're developing this. And added to that, it's about the power of collaboration and like how you can build this platform that brings everyone. It's not only for experts, it's not only for people who are interested, it's not only for decision makers, it's for everyone to communicate around and using this platform. That's where the real power comes. I don't know if anyone has any questions so far, but if there are no questions, I'm going to go from this, more philosophical part of the presentation to more practical part of like how does pollination helps with streamlining the process that we want to do. So the first thing that pollination does, it helps you to create, validate, and repair analytical models efficiently. As you saw, like we figured, that's a big part of the problem in the industry, that people cannot get things done. And I'm going to start with everyone's popular platform, Revit. So to give you a little bit of background, in 2017, I started a project called Dinosaur, which was a package for DynamoBeam. I never really released it, but it was on GitHub. The code was there and was working. And the name comes from dinosaur because it should not exist in the first place. If you have a building information modeling platform, it should give you the information that you need, but it doesn't. Unfortunately, that's the reality. And because I couldn't get Autodesk to help me to solve this, I think like we finally built the Revit plugin partially to solve this problem first and foremost. So what you see on top is what happens if you use the GBXML exporter. If you export if you use the GBXML exporter directly, and what happens in the bottom is if you basically go to HVJSON, which is the format that we are using, and then export to GBXML. And to be clear, this is the same model. It's not like I cleaned up the model for this one and then we use the original model for the one on the top. And people out there, more than myself and our team, think this is this functionality is a breath of fresh air comparing to what Revit has to offer. And even that's true, I have to clarify, it's not a single click solution, right? So I'm not here to show you in any of my slides, I'm not going to show you like we have come up with this solution that solves all the problems like with a single click or it's magical. The reality, and I think that's very important for everyone to understand, is what we're trying to do is going to be effective if we are serious, right? If we accept the limitations that we currently have in the industry. And one of the limitations that we have is like our BIM models, and mainly when we say BIM, we really talk about Revit, right? It's not, our Revit models are not clean. Our Revit models are not ready to be used for environmental building simulation. So how do you deal with that? Is instead of saying, oh, there is this magical single click, we figured out everything for you, is to give you enough tools to help the tool to understand how do you want the model to be interpreted and exported, and that way we can save you a lot of time. So I'm going to show you some of those non-magical but important things that you get from the Revit plugin. For example, we let you tell us which elements are apertures. And I have seen Revit models that people have used wall elements to build apertures. I don't know why, but people do that. Then the other thing is we support room spaces or areas. The reason it's important because during the process of design, when initially things get started, areas are what really you can rely on because designers take care of areas, but they don't even place rooms, or rooms are not something that is cleaned up. And then you have the spaces that mechanical engineers use closest to the end. So we support any of these as the source of geometry during the process. The other one, which I even feel bad to say is something interesting, is we allow you to support part of the model. This was a major headache before because all the other exporters that I have seen they export the whole model. And if you wanted a few rooms to run a test study, you had to get the whole model, which was not clean, then clean up to get like to 2 rooms. And that's where people are just like, I just redraw everything from scratch. The other thing is understanding that during the process of the design and simulation, you need different levels of accuracy. So we have methodologies that just extrude the model. We have the methodology that gives you the whole detailed full model with all the details. Of course, this one takes more time to prepare than this one, which is very quick in the process. And you can mix and merge them. So in this example, we can use extruded floor methodology for the first one and then full volume for the second one. More importantly, on top of all of this is Revit is a place that there are a lot of inertia to change because so many people have ownership of the elements. So it's not like as easy as, oh, here I want to move this room from here to here because this is better for my energy model, or just I want to remove this column not to be room bounding. You cannot do those stuff easily because someone else will be mad at you, right? Because it's important for them. So we have added a lot of solutions that you can get a clean model without really changing the Revit model. This example is you can draw a line and say, this is the align line that I really want. And then during the export process, we align these surfaces to that line based on the tolerance value that you can put in. So this is a real example, real hospital building, 1 floor, I think it was 7 different floors. And if you wanted to go and edit every single room, it would have been a craziness. And what they really wanted was the whole facade of the building, right? The envelope. So you can just draw an area and then you get a clean model like this. So the Revit plugin takes care of all cleaning of all the apertures, merging all of this together and give you a single clean room that you can take somewhere else and split the rooms to different zones if you want. So the first step is basically resolved here. The other thing that makes the Revit plugin different is we are moving beyond GBXML. I really like the idea of GBXML, and we did similar thing with HVJSON, which is the file format that we use for interoperability. But what we saw is if you want to really be able to sell a product that people can trust, you have to go directly to the software. So you write directly to RAD, to GEM, to OSM, to IMP, and to IDF. The IMP one is experimental, we're still working on. But in all these formats, we actually go to HVJSON, and we can guarantee that the geometry goes in correctly. If it doesn't, it's a bug, we can fix it. And depending on the file format, you can actually keep all the data like OSM and IMP. So something like GEM, you just can take the geometry in. There are videos online that you can watch if you want. There is one that I checked this Revit sample model and exported in 4 different software after cleaning it up, so you can see how that works. The way people are using Revit plugin, you're probably thinking, okay, how am I going to use it? I show you 3 different ways that you can use the Revit plugin. One is the most recent. Oh, actually, one is One is the one that mostly used by engineers, building performance analysis. The one that take me out of Revit as soon as possible. So what people want is basically take the Revit model, clean it up, export to any of these formats, just go in a different software, do the work there. That's totally fine, and you can totally do that. This is an example of a model with 2,000 zones that's exported from our Revit using Revit plugin to IES in 7-8 hours. And again, like I put this and put the hour there to just tell you, like, it still takes time to clean up. I mean, this model was in particular had some issues, but this should take an hour or 2 to export. It's not like single click. You still have to review the model to make sure the model looks fine. Of course, we are adding more and more automation, but we're moving people from weeks to days and days to hours. That's how you know, how we think things are going to work. It should work. The other one is the one that is mostly popular by architects. Is kind of like, I don't want to leave Revit ever. You know, I just want to stay here. So doing this one, we recently released a Revit panel, which actually allows you to get the model from inside Revit, run everything, pollination panel inside Revit, run everything inside Revit, and even visualize the result. In Revit, it's not perfect. Again, it's Revit, so you can't change the minimum maximum of the legend. There are stuff like this that we're still working on, but the workflow is there, and you can do all of that by downloading the Revit plugin today. And the third one, which is for more advanced users that we have, and a lot of Ladybug tools community, is basically they take it from Revit, bring it to Rhino, do the cleanup in Rhino, and then either run the study outside Pollination ecosystem or run it inside Pollination ecosystem, or even take it to Ladybug tools, run some parametric studies, and mix and merge everything. Again, this is an option. When I show this, sometimes I know people get freaked out that I need to know like 5 different software. You don't need to. If you're comfortable staying in Revit and just use Revit, that's totally fine. But this is important because then you can do stuff like this one. This is a project that Amir did from Stantec. Now it's actually more than a year old. That basically he took the model from Revit, exported it to Rhino Open Studio for energy simulation, and then used Ladybug tools to run all the parametric studies, and then used Design Explorer for showing the result and exploring the results. Then after that comes the Rhino plugin, which is also helping to deal with this issue of like getting the analytical model fast, getting an accurate analytical model fast that you can use for the study. Any questions so far that you want me to answer? I don't see anything on the messages, so I just continue for now. But feel free to send your questions if you have any during the process. So, okay, why do we need Rhino plugin if you have solved the problem with Revit? Because Revit is Revit. It has a lot of limitations, and there's not much that you can do in Revit. Things gets really slow after a while if you want to do things in Revit. And what the Rhino plugin does actually brings the geometry power of Rhino and adds the power of Ladybug tools on top of that to make Rhino the best tool for generating building performance analysis geometry. Because Rhino geometry is fast, we have all the Ladybug tools has compatibility with all this simulation engines. So when you marry both of them, it's something very interesting happens. Because now you can deal with very large models. I'm a big fan of Open Studio app. I used to use it, but the challenge was when it gets a little bit large, then everything starts to get really slow in SketchUp. But Rhino is not like that. The good thing is Rhino has a very great geometry library, and it's light in general, so you can deal with really large models with no issues. The other thing is we have added a series of validation routines in Rhino that now, before running the simulation and get that weird energy plus error that like shows up somewhere, you can basically run the validation. It shows you what's wrong. It shows you where it's wrong in the model. And then we have other routines that helps you fix it. So that one was for finding the apertures out of the face. This one is another command that helps you find the surfaces that are very close, but they don't exactly match. So the solver JSC will be wrong. So you can find them in the model. And of course, if you can find them, then you should be able to save them. So this is one that helps you with saving all these apertures that are out of the face when they come from Revit or other software. So you just run a command. Basically, we have a lot of commands that we thought, okay, what would a user do, or what I would have done when I had to fix these models manually, and they're not part of Rhino. One of my favorite ones is this one, that basically you get all these models with all the dots, these lines, like this is also in hospital model, things back and forth, missing rooms somewhere, and this is something that from what I've seen, people, when they see this, just like we just redraw everything. If you know Rhino well, you can fix this in like an hour or so, probably one by one. But we saw enough of this that thought like, okay, we can just automate this process, but not like 100% because we don't know which one is the right one. But what if we get the user involved? So this is a routine in Rhino that allows you generate what we call alignment grids. So you select the rooms and you select the grid size that for your accuracy. And based on that, it finds the places in your model that this line's supposed to be, right? It tries to guess. But of course, it's not perfect, right? That's why you can bake it to Rhino, basically. And then after that, go back and manually edit them, remove some, add some. And once you do that, you can imagine if you have a command to generate the alignment line, we should have a command that helps you align them to those lines, so which we do. There is also another video on YouTube that you can watch on the Pollination YouTube channel that I take this model and go from there to this in 15 minutes using the commands that I just showed you. So how are people using the Rhino plugin? The first one is similar to Revit. We have a lot of users that are using the Rhino plugin now to generate the geometry for IES. That's one of the really popular features of the Rhino plugin. And we are making sure that we just support almost everything that we can to make sure, like when you get the model in IES, you don't have to do anything. The geometry is ready to go. Then we have people who use Rhino with Ladybug tools and Grasshopper to make some fixes or like automation to the model and still export it to other software that they want to use. And we have this mentality comes from Ladybug tools and Pollination is the same. Your model is your model. Bring it from anywhere that you want, fix it, take it. There is no mentality of like when you come inside Pollination ecosystem, you have to stay there. And all of this is because we believe this is important to solve that problem that I just showed you, the interoperability, the communication, the way we work together. We can't solve it by staying in a single platform. I don't think that platform exists, and we are not trying to do that. If you have years of knowledge in using other software, we help you to make geometry easier, to help like preparing the model easier, and just go use that software that you're good at. And there's no problem with that. So this is like, these are two videos. I'm not going to play them, but that one is an EQuest model. This one is supposed to show how you can go to IES from Rhino. The other way is similar to the one that I mentioned in Revit, that people just stay inside Rhino and what they want to use is the Pollination. I have a series of videos that shows how it works. So this is an example of setting up a daylight study. So you basically select a recipe, and the model is linked to your Rhino model. So you can just take the model, bring it into Pollination. And then once the study is done, you can also visualize the results back into Rhino. And if it's not clear, the UI that you see here is the Pollination web platform. But when you load the Pollination web platform from inside Rhino, it becomes like a Rhino plugin. You can send the model from Rhino to Pollination, run the results, and run the simulation and take the results back. Some of you might be thinking about, oh, we don't want to run anything on cloud, you know, privacy issues and all those. We totally understand. I think that's also a unique feature of Pollination, that you can switch between a local run and a cloud run by just clicking on this button between cloud and local. So we don't want and we don't force everyone to run everything on cloud. It's not practical, doesn't make sense. You can keep everything local as long as you want. And we provide the UI to actually, let me go to the next video, to actually get all your local runs, just like how you get all the cloud runs. So you can go to see local studies on your machine, and you can click on it. The UI is the same. You can see all the inputs, all the outputs, and you know, you can visualize them inside Rhino if you want, or you can visualize them inside the interface. The other number 3 is, again, the one that people are using, which brings all of them together. People who use Rhino with Ladybug tools and what it has to offer. And I don't know how many Ladybug tools users are today on the call, but as I said, I see a very great synergy between the two. So this is an example of, you know, if you want to add shades parametrically, so you can use a Grasshopper script to add those shades, put it in into Rhino, and then use the Rhino model from there. Everything is now a Rhino object. Or you can basically now, if you run anything with Ladybug tools and you have all the Ladybug tools and stuff, before, if you bake them to Rhino, they used to be only a colored mesh. Now with Pollination Rhino, when you bake them, they are a smart object. So they are what we call analysis mesh. And because they're analysis mesh, they have the data. That means you can always go back and edit them. So the good thing here is now it's part of your Rhino document. So you don't have to send a Grasshopper script with the Rhino file. And whoever has the plugin and opens the Rhino file now has the design model and the analysis model, both of them in the same file. Then I'm going to use, again, another testimonial that it's a brutal quality of life enhancement over OpenStudio and only using Grasshopper. And one of the things that we use the most is this is how a Grasshopper script looks like, if some people on the call haven't seen a Grasshopper script. And this part is what you do to set up the model when you bring the model from Rhino. And this part is really the part that we had to click for QA/QC, make sure things are assigned correctly, the program is correct, and all those. And oops, sorry. And this is only the part that we use for running the simulation, right? Now, this is how it's looked like, because the whole model setup in QA/QC is in Rhino. You just can reuse the logics that you have together in Grasshopper. And of course, you don't have to. You can do all this from Rhino too, but Grasshopper gives you this level of flexibility that Rhino cannot provide. And there are parametric studies, of course, that you can do in Grasshopper that's not easy to do in Rhino. This is an example of how our scripts now start to be very small. Instead of having all those logic, it's only like, okay, this is for energy, this is for annual load balance, this is for running a daylighting study. And a lot of people have started to ask us about detailed HVAC because the Rhino plugin is making things easier, it's fast. You can build deal with geometry, but we have HVAC templates, detailed HVAC templates. We use OpenStudio under the hood. I forgot what's a standard. Something the standards from OpenStudio. If you have I'm sorry to forget that. But people wanted more than that. People wanted to be able to edit all the details of the HVAC. And there is another plugin that's called Ironbog that Mevo developed, who's part of our team, on top of the OpenStudio SDK. And we are now exposing that. So you should be able to run detailed parametric HVAC studies on top of your model in the Rhino plugin soon. Just to give you an idea where things are going with the Rhino plugin. But it's more than just building geometry, right? So I talk about geometry, getting all this stuff, running the studies there. They are important, and I think they're a big part of the issue that we have in collaboration. But now that you can build your geometries quickly, you also need to build and customize and reuse environmental building simulation workflow. And what I mean by this is I have lived this life of we have a solution that people say, oh, I want to run daylighting like this. Oh, we can only run it from Rhino, you know, like we are in Revit, so export everything back to Rhino, or we are in SketchUp, so I can't do this. We can only do. So you have all these things because the thing is designed to only run inside a very specific platform with a lot of integration to that platform. It's not necessarily a bad thing, but it doesn't help us to solve the problem that we want to solve. So because of that, we basically developed a new kind of language to write the recipes. And we learned a lot about software developers and how they do stuff that you just write a definition, write a description of what you want, and it can be translated to different platforms. So now when you have a pollination recipe, for example, annual daylight, this is how it will look like from the web interface. You can put the geometry in, you can put the weather data in, and it will run. This is how it will look like from the Rhino interface. The only difference here is this button changed to be get model. So you can click on it and it gets the model from Rhino. And this is how it will look like from the Revit interface. And if you felt like, oh, the Rhino and Revit interface are not that different, that's correct. And that's the point. When you're running the same thing, the UI shouldn't be that different because it's the same thing. The only difference here is when you click here, get model, it gets the model from Revit. When you do get model here, it gets the model from Rhino. And you can also reload it to something like Grasshopper, which is a very different animal. But it's still, because it's a definition, you have the inputs and you have the outputs. So you can reuse all these logics in different platforms. You can also reuse these logics on different, operating systems. That means like you can, for example, run the recipe locally or run it on the cloud. It's the same thing. And you don't have to be worried about like all the differences. The one on the left actually is running on Windows. The one on the right is running on Linux. And this is the same recipe. That's also important because it will save you a lot of time as you are making these workflows that you have for energy, daylight, comfort, glare better. When you make them better, they should be better in all the platforms that you have. It shouldn't be, oh, the Rhino is updated, the Revit is coming, the SketchUp is like in 2 years, something like that. It's basically the same workflow that can be executed from different places. Also, it helps you to boost productivity in a scale simulation. Why does it matter? Because even when we do all this stuff, if we still cannot communicate and collaborate, if we still have to send like big models and files, and then you see the file there and you don't remember which computer that was from, we can't still work together well, right? So that's why Pollination also provides a collaboration platform. So in this example, I'm going to Ladybug Tools, a demo project, and I'm seeing all the runs that have been executed. This is from Chris. We have a viewer to allow you to do a quick check online to make sure, like changing the colors, checking the input files to make sure the input files are correct, checking the output files. And of course, you can also take this model and bring it into Rhino for review and doing all that. How does it select what is context and what is the building space to be evaluated? If, say, I only want to analyze few rooms of a larger building. Mark, is the question for Rhino or Revit? Revit. In Revit, there is a separate place that you select the shades. There is a separate step there you place the shading elements, and there's a place that you pick the rooms, and you can pick which rooms exactly you want to export. Good question. And if you have time, I can just show it to you live. But continuing on this, the other thing is, so that one, the first one is we are trying to solve this delay of people getting in the way of each other. You have to have that person to give you that file which they ran on their computer. That shouldn't matter anymore. And the other thing is you want to run things in scale. So again, it's an option, but if you want to run studies in scale, now you have Pollination is there, just a few clicks away to run something on cloud, and it will work with all the other things that you have in the CAD platform. It's very important for me. I don't know, like, and this is a feedback that we get a lot from a lot of our users, is that you do not have to leave the platform that you're working on. It's not like you save it, load it somewhere in the cloud, and then after that, you start working on the cloud. Again, that's an option, but as soon as you do that, you basically separate this thing that's changing your design model from the analysis model. Of course, as you get later in the design, that makes a lot of sense, and you can do that. And as I showed, we totally make that available and possible. But I think there is value in being able to stay in the platform that you're comfortable with to work and use this simulation as a service. So we have two cases that people use the cloud computing. One is long-running tasks that people want to set up and just free up the computer for hours. And the other one is you have companies coming and like running large parametric studies. And now actually we're getting to a very good place that there are companies that are coming and running a smaller parametric studies on pollination. So this is the last segment that I'm going to talk. There's a question that is CFD analysis for natural vegetation using OpenFOAM available for Revit app? It is not. We're not supporting CFD, but we are in touch with two companies who are providing CFD as a service that we might build apps that allows you from Revit use their services to run the studies. We haven't, right now we have everything that we can run with Energy Plus and Radiance, which means energy, daylight, comfort, glare, all the ones that I mentioned. But now going back to the presentation, on top of everything that we have, we know as a company, we cannot keep up with everything that we need, right? Or the industry need. And because of that, we have added pollination apps. Pollination apps are basically Python scripts that you write that create web applications. We use a framework called Streamlit. But where the magic happens is if you load the same app from inside Rhino or Revit, they become a Rhino plugin or a Revit plugin. So you can think about the web plugin that when you run it from Rhino, it becomes a Rhino plugin. So this is an example. Oh, before that, this is an example of like how we think people want to use the app, right? You want the app to be used from inside Rhino and Revit by your end user. And this is something that happens on a daily basis for us when we use our phones, right? You just go here, there are hundreds of apps that other people have developed, and you just click on them and they do something very specific. So the key here is not to build only the interface that supports this, but also build the whole infrastructure that you need. Developers can basically develop these apps and deploy it to Pollination and everyone else to be able to use. So we have not only our apps that you can use, you can develop your own custom apps and deploy it to Pollination. I should make sure I say that apps are still beta, like we're still developing apps, so there might be changes, but we have companies who are already using apps on their projects and they're quite happy with how it works. The value proposition of apps, similar to recipes, is now when you have a solution on your local machine and you want to get other people to use it on cloud, it takes minutes instead of taking months of setting up everything. The same of like if you run something which is very small and now you want to run it with like hundreds of options or thousands of options, now it takes minutes to deploy once you have it ready. So the deployment is not a problem anymore. And we are making it easier and easier. So this is all the lines that you need to write to basically create an app that does all the simulation that I showed you, that you can select the recipe, you can start running a simulation and then visualize the result. One application that we have seen for Ladybug tools users is we saw like people have different Grasshopper script that they're slightly different, they're not the same, and like offices are really have to deal with this of like how to update them. Now you just have a single recipe or a single app and everyone is going to use that. So you update that, everyone gets the latest and the newest version. This is an example of the app to give you a visual understanding of like how it can look like more than that sun path. So this is an app for running incident radiation. It allows you to select geometry. It allows you to select context. This is now, we're running the app from Rhino. You select the weather file and then you run the study. Because the apps is inside Rhino, it's going to connect this. It's like a plugin. So if you make changes or if you want to select something new, it listens to changes and it will rerun. This is how you can use it kind of like for during the design process for design iterations. The other one that I want to show here is similar to recipes. When you have an app that works in Rhino, it also works with Revit. Of course, depending on what the app wants, you have to make sure your model is prepared correctly. So this app is an energy balance app. So you can run the balance and heat balance, and then it shows you all the load balance, or as a heat balance. Load balance, it shows the monthly load balance and all those graphics that you can go through. Okay, so let's wrap it up. After all this thing that I said, what is pollination finally? So pollination is an ecosystem that's trying to solve this and change it to this. Now with pollination, if you have the same kind of discussion, the same deadline, pollination is this invisible platform in the middle that brings everything together. So instead of waiting for the model, you develop a recipe, a solution that you deploy, and the user on the other side uses it and tests that recipe to run it. They give you feedback. You can change the recipe to an app to have a better user interface. They keep using that, you don't have to deal with it on the other side. They don't have to find you to run their studies. And once it's done, you can have a version 1.0 of the app that you can reuse later. You gain all this extra bonus time. People have access to what they want at the right time. And more importantly, people can move between different platforms during the design process. And that's not a problem. And of course, you can go on vacation if you're on the simulation side of things, and people even won't notice how that goes. This is a single chart here to give people an idea of like how things work. I won't go through the details, but basically, this is a hybrid solution. You have desktop here, so you can only use it as a desktop solution if you want. You can use it only as a cloud solution if you want. And with apps, kind of like you can stay in the middle, that you can use it from local or run the studies on cloud. It's an ecosystem. Whatever we do, we end up like building a chart like this that connects everything to everything else. I put it where iPhone generation 1 was. We have developed the apps, but they're not that many. We have the whole cloud infrastructure that works on top of. We improved the user experience for the tools that were available before. And we have solved this custom issue with the customizable UI that I think was a big part of the iPhone itself success. Everything that I showed you today, you can download and use. There's nothing that I showed here that's not available. So you can go to pollination.cloud, download all the products. CAD plugins are 14 days free trial period. Grasshopper plugin is free forever. Cloud computing, we give you 3 hours for free. So there's nothing to stop you getting started. And again, everything that I just showed today is accessible right now. Online, you can download it. And you will be in good company. Initially, when we started, I think there was a little bit of concern from companies of like, who else is using it? Is anyone has tested it? It has been tested. People are using it. I'm not going to tell you like everything will work perfectly. That's no software is that. But the critical path has been tested on several projects and it works pretty well. Finally, if you are a company who wants to do this, but is not confident or doesn't have the resources, we are here to help. You can reach out and we can help you during the process to basically build this transition to pollination or integrate pollination into your existing workflows. With that, I hope you enjoyed the presentation and I'm looking forward to your questions, if any. And I see there is a poll here. Can you describe notable differences between pollination and Cove tool? The strength and weakness, can these tools complement each other? So I've been asked these questions frequently. We had actually one on Discourse recently asking about, let me go here, asking about the difference between pollination versus Autodesk Insight, right? So I think, again, like I think the main difference here is the design philosophy. Pollination is not designed to just like say things are simple, everyone can do everything. I think the design philosophy is about flexibility and streamlining the process. I'm not the best person to tell you like how much detail we can get into with Cove because I haven't tried their tools. But I think high level is really design philosophy. That's as much as I can go in this live presentation. Let's put it that way. Was one of the CFD services in scale? I have found it difficult to use Butterfly on building scale. Yes, yes, and we now that we named SimScale, the other one is the one from RWDI team that they are working on, and orbital stack that we have talked to. But it's not, technology is not necessarily the problem. The licensing is the part that makes things a little bit complicated. Next question from Aaron. Going back to recipe, is it fair to use an analogy that they are like schemas for files, applications, etc. to exchange data? Recipes are schemas for workflows. Yes, there are schemas. They are written under the hood. They're written in YAML format. They're very similar to what CI/CD people use. Like if you know Kubernetes, they're basically very similar to Kubernetes specification. They're a specification, I would say. Yes, that's very close. And because they're written in YAML format, then they can be translated to different formats as executable. Could you give a bit more info how Pollination changes the workflows here, where I run parametric recipes in Grasshopper? I quite often add windows using the window to our ratio mark. So it doesn't. It's for preparing your model, you can actually use all the Ladybug tools part to do that. The difference is when you want to submit it to Pollination, you basically collect all those runs and submit them all together in one go to Pollination, so it doesn't run one at a time. So if you have 100 simulations, everything runs in parallel on Pollination. There is, I don't know if there is no other question, I can maybe show that part to you. So this is how it is. So the recipe is very similar. You create runs, you collect them, and then you connect the runs here and pollinate. So instead of running one at a time, you can basically bring a recorder here, recorder here, and then create your different models, create several, runs, and then record them here and submit them to Pollination altogether. And this is something it's well documented on Pollination website, and there are examples you want to see. You can of course also reach out on Discourse, and then we can help you there.
Can you hear me? Can I ask a bit more about that?
Sure.
Yeah, what I actually meant was I quite often use a mass in Rhino, and then I use the window component to add a window to wall ratio, and then I run, say, a daylight simulation on that. Where does Pollination fit into all of that?
So let me then ask a clarifying question. So if you use Rhino to do window to wall ratio, then is it a parametric run?
No, I use the Ladybug tool, the Ladybug, the Honeybee module, and I take the mass
to do that.
and then I add a window using the window to wall ratio. And then I run a Ladybug, a daylight simulation or energy simulation or something.
That's totally fine. So the reason you might use Pollination is, one is if you're not comfortable with Grasshopper and you want to bring most of the workflow into Rhino, that's when you use the Rhino plugin. The other one, if you want to run hundreds of them and you need cloud computing, you do Pollination. The third one is if you want to share the results. So if you run the study and you want other people in your team or your client to be able to see them online, those are the three cases that Pollination comes in.
Yeah, I think we want to also bypass. We want to go straight from Revit so that they can. That's what I'm trying to get. If I've got a user and they're in Revit and they draw a mass, can I use a similar type of recipe where I add a window to wall ratio and then run it in Pollination?
Yes. Yeah.
And so it's not, and then it's bypassing the whole Rhino environment.
Correct.
And that kind of scripting, because I can do that, but the architects I work with, they just want to, as you say, they just want to work in Revit. They just want to kind of click that mass and go add 20% window to wall ratio on the south and run the daylight study and tell me the results.
So how it works is basically this is the panel in Revit, and it has access to Revit. So any recipe that you add, so if I go, to my projects, also just assuming you have that,
and these recipes are just like the same Grasshopper files, if that makes sense.
No, the recipes are that YAML definitions.
Okay.
That's the one that I was saying. So if you have any recipes, then you can select them And let's say you have the new recipes is called parametric daylight studies. And then these are very typical. So if you want us, we can help you either with a recipe or an app to create that. And then after that, basically the user now can get the model, click here and get the model from inside Revit environments, right?
So I wouldn't load my current grasshopper recipe up into Pollination. No. It works different.
Right, it works differently. You can't deploy the Grasshopper script directly as a recipe.
Right,
because, yeah, Grasshopper is not as flexible to be translated to all the things that we're doing.
Okay, but I guess you can still build in these modules.
Yeah, because the whole thing is all this recipe is also using the same Ladybug tools that are inside those components in Ladybug tools, Grasshopper definition.
So where do you build those recipes in Pollination? Is it through scripting, or is it like it's not like the Grasshopper environment where you connect them all together?
Right, it's in Python environment. So if you go to, that gets really technical. I think now people.
Yeah, I think that's what I'm trying to understand.
Going to be like what's going on, but I'm going to show it to you. So here is a post of how to write your first recipe in Pollination. I'm going to send it to everyone. Hopefully it doesn't scare anyone. What happens here.
I guess that's this is the thing that's a bit tricky, is I will go from an environment where I can use the wires and Grasshopper to connect all these things up, and now I've got to do a bit of Python scripting instead, I guess.
Right, that's the difference, and that's what we are trying to basically help the community to move, because when you do the Python scripting, then it can run anywhere and everywhere. The challenge with Grasshopper is just like it has its own limitation. I mean, there is Rhino compute, but
it's just, I like the Ladybug bit where you can, as I say, you can take a mass and then you can just sort of throw a bunch of shading onto it and whatnot. I guess you could bake it, like you said, you could bake it and then you could send it up to Pollination. You could do it that way, I guess.
Yeah, you can, totally. So we have a question here from Corey. Every time I ask an architect to export from Rhino to gem via Pollination, I get a gem that says VE says this crop. So I think like this is a user problem, because we have very good experience with the export. Can you, if you send me the models, I'd be more than happy to help and check that out. That's something that should definitely work. Okay. Any other questions?
Hi, Mostapha.
Hi.
I asked this question to Chris during the Rhino plugin workshop in London this week.
Okay.
So he just mentioned about one thing, that is there a major upgrade coming to Revit plugin? Because, you know, as far as we can see, it was coming a little bit behind the Rhino plugin.
Yes, I released it this morning.
Fantastic. Thank you.
Yeah. And I think I mainly did it so during this presentation, I can say everything that I showed you guys, you can use it today. They're very, I wanted to release it after we fixed the legend, but yes. So it's yes, you can basically now run anything and everything from inside the Revit plugin using the panel.
Thank you.
Yeah. Okay. Absolutely. Any other questions? I think Dylan, you can take it from here. I don't see any other questions. Okay, I think I don't know if they're still there. I just want to thank you, everyone, and I think this should be the end of this this presentation. You can always reach out to me at Mostapha or Pollination CAD or discourse.ladybug tools. We'll be happy to help you with any follow-up questions. Take care.